Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabat College, University of Delhi. So in our previous lecture we have started with our procedural query language, which was named as relational algebra, and we have seen that this relational algebra is actually a procedural query language in which we perform the task of extracting the data or the information from the database with the help of following operations. Now what operations I am talking about? These operations are select, project, union, set difference, set intersection, set difference, Cartesian product and rename operation. Some of these operations are applied to a single relation, some of these operations will be applied to a pair of relations. So now let us see them, let us try to understand them one by one. Let us begin with our select operation. So the select operation basically selects a tuple, that is tuple as in a row, that satisfy a given predicate. So we have a condition, we have a in relational algebra we call that condition as a predicate, and the tuples, the rows which are satisfying a given predicate will be we can say selected, and then a new relation is being formed. So it is denoted in relational algebra, the select operation is denoted by the letter sigma, and the notation of the we can say whole query or whole operation is sigma then a p within the bracket r. So sigma is for select, p is actually the predicate which we want to give. I will also give an example of this, and within the bracket what r is actually the name of the relation. So sigma is used for the selection, r is used for the relation, and p is actually a propositional logic formula which may use connectors. It can have and, it can have or, it can have not, and all these relations can use as relational operators like equals to, not equals to, greater than, less than, greater than equals to, less than equals to, and so on and so forth. So let us try to see this with the help of an example. So here we have a relation which is named as loan, in which we have branch name, loan number and the amount. These three we can say fields are there. Now let's say we want to select, or we want to we can say extract all those tuples or all those rows where branch name or where the branch name is PeriWrite. So we will be writing sigma, then we need to write the p as in predicate along with the propositional logic if it is required. So that predicate is branch underscore name. Now branch underscore name, as you can see in this relation, is the name of the field, is the name of that particular attribute. So where branch underscore name is equals to PeriWrite, and within the bracket we need to write the r is the name of the relation. So on execution of this select operation we will be having a result as in with the same attributes as that of the original relation loan, because we have not selected here the attributes, we have not selected the columns, we have only selected the rows. So we have branch name, we have loan number, and we have amount, and only the branch name where only the information or only the rows where branch name is equals to PeriWrite are being shown here. So PeriWrite, loan number, then amount, and the next one which is also having branch name, loan number, amount. So all the we can say rows, all the tuples who are satisfying, which are satisfying this branch name is equals to PeriWrite are going to be selected. So in this selection what are we going to do? We are going to select some specific tuples from maybe one relation, or we can say multiple relations. Now when it comes to multiple relation, we will be showing that as well. Presently we are focusing only on the a single relation. So let's say we have another relation which is named as instructor. Let us take one more example. So that instructor relation is having ID, name, department name and salary as its features, and within the instructor relation we want to select only those rows which satisfy a particular predicate of salary greater than 85,000. So salary greater than 85,000, all these rows, tuples will be selected, and we are going to have a new relation when we are going to write sigma, then salary greater than equals to 85,000, and within the bracket we will be writing instructor, which is the name of the relation. So we will be having ID, name, department name and salary for all those instructors where salary is greater than equals to 85,000, and the result will look like this. So this was basically we can say was having one of the most common or most basic, most frequently used operation under the relational algebra, which is the selection operation. Now coming to our next, which is the operation of the project operation. So project operation is going to show the list of those attributes which we want to appear in the result. So in the select operation we have extracted, we have selected some rows. Here in project operation we will be showing the list of some attributes which we actually want to be there. Now other attributes will be eliminated from the result. They will not be shown in the result, while they still exist in your original table. Now as the select operation or the operation of the selection is being denoted by sigma, here the project operation is being denoted by pi. Now apart from this we have all these attributes we will be writing as the names. So for example, pi a1 a2 till an from the relation R, where a1 a2 a3 till an are the attribute names of the relation. So please be careful here that here we are just using, we are directly using the attribute name of the relation. We are not putting any predicate, we are not putting any propositional clause or any condition here. So for example, here we have a customer relation which is having three attributes. One is name, another one is street, and third one is city. Now let's say we want to select a particular or maybe more than one attributes from this particular customer relation. So how are we going to write? So we have written pi name comma city, and in the bracket we have written customer. So we are going to take the two columns, one is name, another one city, from the customer, and here is the result which is being shown on the screen. In this, the feature or the field which was there in the original one was street has been eliminated. So in this project operation we are selecting the columns, we are selecting the we can say attribute based on their name. There is no, here we don't have any condition being put, any specific condition being put on the columns, only the name is there. Then apart from this we have one more operation. Coming to the next one is about the union operation. So union operation says, suppose there are two relations, one is named as R, another one is named as S, and there are some obviously some information, some tuples are stored in this. So the union operation is going to contain all the tuples that are either in R or in S or both in R and S. So please recall your normal union operation. So for example, we have two sets A and B. So your A is having 1 2 3 and B is having 2 4 6. So union of A and B will have 1, 2, 3, then 4 and 6. So it is it also going to eliminate the duplicate tuples. So similar similar union fundamental we are going to use here on the relations, that is the result of the union operation will contain all the tuples that are either in R or in S or in both R or in both R and S, and the operation, as the select operation was denoted by sigma, the project operation was denoted by pi, this is denoted by U. So the notation will become R U, U as in union, and S. So let us see, but before going into the example of this thing, your union operation, we need to see the conditions which are must for the union operations. So a union operation must hold the following conditions. One is R and S must have the attributes of the same number, that means the number of attributes should be same, and duplicate tuples are eliminated automatically. They are not going to be recorded in the result twice. So for example, we consider two relations. One is the depositor relation having customer name and account number. So some customers names and some account numbers are given. Similarly, we have another relation which is the borrower relation, which is also having customer name and the loan number. So similar number of same we can say attributes, same features, same attributes, same fields are there. So now if we want to take a union of borrower and depositor, so depositor is a separate relation which is having customer name who have deposited some loans or something. Similarly, the customers who have taken some loans are recorded in borrower relation. Now for example, the bank wants to know that with all whom the bank is being transacting, either in the form of depositor or in the form of or as a borrower. Then we need to take a combination of these two, and that combination will come with the help of union operation. So how are we going to take the union operation? So here if we want only the customer name, so first we will be we can say projecting, we will be taking out customer name from the depositor as well as customer name from the borrower, and then we will be taking a union of this. So how are we going to execute is pi customer name from borrow union pi customer name from depositor. As you can see this on the screen, from the borrow we have taken customer name. We are not going to apply union on the whole we can say on all the columns of the table. We will be picking some specific columns and then we will be applying union, and these columns should be we can say common. So here customer name we have taken from borrow, similarly customer name we have taken from depositor, and after taking these with the help of the project or projection operation by customer name from borrow, by customer name from depositor, we are going to operate or we are going to perform a union on these two, and the result is here in front of you, which is having the name of the customers which are either available in borrow or are there recorded in depositor, but or in both of them, but the duplicate results are eliminated. You won't find duplicate results here in the union operation, and that's the we can say normal scenario of a union operation. Apart from this, the kind of we can say other side of the coin of the union is the set intersection operation. So set intersection says that let's say there are two relations, one is R, another one is S, and the set intersection operation contains all the tuples that are in both R and S. So that means the common tuples we are going to take. So it is denoted by the sign of the intersection, which is the inverted U, and the notation will be R inverted U, or the symbol of the intersection, then S, where R and S are two relations. So for example, using the same depositor and borrow relations, or using the same depositor and borrow table, we will be taking pi customer name from borrow and pi customer name from depositor, and we will be performing a set intersection operation onto this, and by this set intersection operation we are going to have the names of all those customers which are available in both, that is in borrow as well as in the depositor. And here we have only two customer names, one is Smith, another one is Jones, that are which are common in the borrower as well as in the depositor relation. Now next is the next operation which we are going to consider is about the set difference. So set difference, again let us take two relations R and S. So set difference operations contains all the tuples that are in R but not in S, and it was denoted by minus. So R minus S. So for example, if we are going to use the similar we can say tables, it is going to give me pi customer name borrow minus pi customer name depositor. So we are going to take customer name from borrow, and we are going to take customer name from depositor. We are going to apply a set difference operation on this, which is pi customer name borrow minus pi customer name depositor. So that means all those customer names which are there in borrow but not in depositor will be given. So there are four customers name. If you can see this you can see the structure in the previous slides of this borrow and depositor relation. Then borrow minus depositor, if we are going to take with reference to customer name, we are going to have four customer names here, which are Jackson, Hayes, Williams and Curie. All these four are available in borrow but not available in the depositor. Then the next one, we have the Cartesian product. The Cartesian product is the next relational algebra operation, and the Cartesian product is used to combine each row in one table with each row in the other table. It is also known as cross product, and as it is known as by cross product, it is denoted by the letter X or cross, we can say, and the notation is E cross D, where this E and D are the we can say tables or relations. So let us see this with the help of an example. So here we have one table which is employee, having employee ID, employee name and employee department, and employee ID is 1, 2, 3. Name is Smith, Harry, John, and department is A, C and B. Along with this employee, we have the department table or the department relation, which is the department number and the department name, that is A, B, C, and the department name is marketing, sales and legal. Now if we want to perform a Cartesian product of employee and department, we are going to write employee cross department. Here please make a note that we are not going to take any we can say any specific selection, or we are not going to make any specific projection here also. So along with employee ID 1, if you can see, the employee department A is being commented. Then along with 2, there are 3 rows of employee ID 2. There are the employee department C has been taken, and along with employee ID 3, the employee department B has been taken. So one has been taken along with A, one has been taken along with B and 1 has been taken along with C also. Similarly, we repeat all these for 2 and 3 as well. So here we can say that we need to combine each and every row in one table with each and every row in other table. So here in the employee table we have 3 rows, and in the department table also we have 3 rows. So each and every row will be multiplied by each and every row of both the tables. So 1 multiplied by all 3, then second multiplied by all 3, and then third multiplied by all 3. The total number of rows in our resulting relation is going to be the number of rows in the first relation multiplied by number of rows in the second relation. So here in this case it is 3 cross 3. So we will be taking one whole row, which is 1 Smith A, and then we will be we can say joining department name and department number, which is A and marketing. Then we will take the same row and write it with B and sale, and then we will take that same row, first row, we will write it with C legal. Then we will be taking second row, write it with A marketing, second row from employee, write it with B sales, third row from employee, write it with C legal, and similar treatment will be given to the third row as well. Now let us take one more example of this. Here is a customer table which is being shown here with ID, name, age, address and salary, and having 7 tuples or 7 rows. And we have order tables also, which is having 4 rows, as the columns here are order ID, date, customer ID and amount. And if we want to take a Cartesian product of this customers as well as the orders, we are going to write customers cross orders, and here is the result, which is taking the first row of the customer table with name as Ramesh, and we can say inserting this or coupling this with each and every row of your next table, which is the order. So the first row, which is Ramesh, has been taken and it is coupled with all the 4 rows. Then the second one, which is Khilan, has been taken, coupled with all the 4 rows here. Similarly, the third row is taken and coupled with all the 4 order IDs or all the 4 rows here. So this was basically your Cartesian product, in which your we can say number of rows in the resultant relation will be number of rows in the first relation multiplied by number of rows in the second relation. So here in the previous example we are having 7 in the customer and 4 in the order ID. So 7 multiplied by 4, this is going to give us total 28 rows. Similarly, we have one more operation, which is the rename operation. As the name indicates, this rename operation is used to rename the output relation, and it is denoted by the symbol row. And if we want to rename the relation student to student 1, we will be writing row student 1 comma student. So the new name first, which is to be which is going to be the new name, comma the original name or the old name. So row student 1 comma student within the bracket. So here in this lecture we have seen many of the operations of relational algebra, which are your set select operations. Then we have project operation, we have seen union. Apart from that, we have seen set intersection, set difference, Cartesian product, and also the rename operation. And here is a list of references which is being used for the preparation of the lecture. Hope you have understood and enjoyed the lecture. Thank you for a patient hearing. I'll be soon meeting you in the next lecture. Till then, goodbye. Take care.